Thank you for that kind introduction, and thank you to the ICOSES committee and everyone participating, especially those participants and attendees today. I'm Greg P. Smestad here in San Jose, California. It's early morning here, not so early actually, 9:07 in the morning. But I greet you then here from California and hope that we can talk a little bit about solar energy related engineering and entrepreneurship in emerging market countries. Now, I taught a complete course in this at the University of Santa Clara, which is my undergraduate university here in San Jose and Santa Clara, Silicon Valley, as you might know it. I came back to my undergraduate university to teach graduate students and undergraduates these kinds of topics that overlap my field of solar energy and material science, policy, and economics. And so you're going to see a little bit of that mix in here. This is an updated version of some of the materials that I have presented to my students as well as through the years since. And I hope that I can advance this. There we are. Oh, there's a little delay. So we are going to first present the agenda. You see the agenda, correct, everyone? Ahmed, you see the agenda?
We see, yes, exactly.
Good.
Yeah.
Yes. So first, the emerging and developing emerging markets and developing economies. I'll talk about what's called a value a migration table. We'll talk about the context in terms of less developed countries. I'll give you an example. We'll remind you of the diversity in different kinds of photovoltaic technologies, in particular agro-photovoltaic technologies. And I'll mention one of several techno-economic tools that is available to bind all of these concepts together in such a way that development is better understood and more easily communicated to a wide range of audiences. And then we'll have conclusions. So emerging markets and developing economies, which we're abbreviating EMDEs. This is from the World Economic Forum recently, which highlights that emerging markets hold 70% of the planet's renewable energy potential and 50% of the materials, like minerals, needed in clean energy technologies. The World Economic Forum's network to mobilize clean energy investment in EMDEs is a community of 45 ministers and CEOs aiming to accelerate the financing of energy transitions in emerging and developing economies. That's, of course, important because we can have the best technologies there are, but yet if we do not have the finance and investment to scale them up, we cannot bring them to market at cost and to serve billions of people who can benefit from these technologies in the energy transition. So just some examples of this World Economic Forum network to mobilize clean energy. Some of the partners include Trina Solar. There's a gentleman there who is the chairman and executive officer. Industry involvement includes nonprofits, including one here in the United States, RMI, formerly the Rocky Mountain Institute. Governments include your own at Morocco. I don't know if this is still the minister and delegate to the head of government in charge of investment, but it does highlight that these things are of paramount importance to the government of Morocco and other nations. This is just a partial list of these 45 ministers and CEOs and organizations that have come together in a collaboration to make things happen in terms of clean energy technology implementation. So there's more at the World Economic Forum website about this. I'll be referring back to this from time to time. So they point out that 1 in 5 emerging markets now have a larger share of renewables in their energy mix than the average developed country. In some ways, these countries are already leapfrogging over the development pathway that what we consider developed countries, like my own United States, have done, leapfrogging over the mistakes to a cleaner and more economically sustainable future. Although the developing countries are home to two-thirds of the world's population, they contain just 20% of the world's fossil fuel production and reserves. This means, of course, if they want to get energy from fossil fuels, they are going to have to finance that, often through debt. Meanwhile, these economies hold 70% of the planet's renewable energy potential. That means they have wind, solar, biomass, all of the sustainable resources in order to meet their needs and needs of other countries as well. And of course, they have 50% of the minerals needed to in the clean energy technologies that we'll be talking about. Here we have an example, of course, again in solar. So the potential is there, the need is there, and the alternatives are to turn to the pathway that other countries have done, the developed countries have done, the more developed countries have done. But RMI estimates that 70% of the developing economies are in green energy, in what's called a green energy sweet spot. What does this mean? This means that they're in a middle income or above the population, have a low energy demand per capita, and have vast renewable energy potential. So this creates a unique opportunity, these conditions. So according to the IEA, by 2030, renewables will cover 50% of the electricity demand worldwide. So as I pointed out, 1/5 of the developing nations have already overtaken advanced economies in the share of wind and solar and other renewables in their electricity mix. This includes Brazil, Morocco, Bangladesh, Vietnam, and Egypt. These are some of the case studies that the Rocky Mountain Institute, RMI, and the World Economic Forum have highlighted in an associated report. All right. So to give some detail to this pathway, this pathway that I talked about that could be leapt over. This is the traditional way of looking at the development of a nation. It is centered on how the more developed world has developed, but it's not necessarily the only pathway. So, of course, we have in the beginning, this first line, we have an agrarian society. Economic drivers were unique, land and crops. There were certain types of infrastructure, dirt roads, couriers on horseback. The economic indicators are commodity prices, and there was no environmental protection. Oops. Okay, what we call the Industrial Revolution, what the developed nations, the more developed nations call it, the Industrial Revolution, cheap steel, coal, and textiles. Again, there were specific types of infrastructure, railroads and shipping, and economic indicators are the consumption of pig iron and cotton and coal, et cetera, et cetera. And again, no environmental protection. Then we've gone, of course, to mass production. Where we've had cheap energy, especially oil. Infrastructures are airports and highways and telephones, et cetera, et cetera. Economic indicators, again, change. And of course, there's command and control development of strict federal regulation. Now we're in a post-1980 technology information era in most of the more developed world. And this relies on drivers of ever cheaper semiconductors, photonics, R&D programs, technology change. Infrastructure is in space, fiber optics, wireless systems, et cetera, with specific economic indicators that are specific to that. This is, of course, one way to look at the development of a nation, but not all nations need to go on this particular road, this particular linear pathway. So we are now, many nations, looking at sustainable energy and information intensity era. So the economic drivers are transition from extraction-based technology to sustainable or circular, which is not written here, but it's implied. And we will eventually have a convergence of electric power and information technology. We're already having that in what's called the smart energy grid, smart residential and commercial buildings, and smart vehicles. Economic indicators are listed here. Those are different. So one could say, okay, to develop a new area or a new country or an area in a developing nation, one can go through all of these stages again, but one can also leap over and go directly to this. That's the point. All right. So what are the economic drivers in this new era, this hopefully sustainable way of developing? So my colleague Joseph Morabito has called these the 7 Cs. C's because its cost is important, capital, competition, and cooperation, the right mix. China, of course, cannot be ignored. It's developed many of these technologies and is supplying them to the world. Consumers, climate and conservation, carrying capacity, how much an area can actually support for either an industry or a population. And then there's a convergence between these different concepts, as well as the convergence of information, biotechnology, sustainable energy, and artificial intelligence. So if you keep all of these things in mind, these can be the economic drivers for a clean energy future, as well as a way of developing policies to drive that economic development. All right, so there are many problems in resource use and development. On the left-hand side, most of these problems are exponential phenomenon. Of course, we have human population, either globally or regionally. We have global energy, industrial production. We always want to have growth in economies, but that requires growth in energy, as one can see. We have growth then in pollution unless we find ways of mitigating that or making a more circular and sustainable economy. And of course, this pollution can lead to deforestation, soil erosion, and pollution of water, which I should have listed here. The solutions, though, are also varied, and these we call resource wells, places that you can draw from. Information intensity technologies. This is how information can be shared both by businesses, by policymakers, by scientists in a common framework. It's given the name information intensity. Global intelligent networks, science-based international cooperation, and again, artificial intelligence. These are things that can be used as solutions to the things that I've listed on the left-hand side. Ecological processes like carbon capture, again, can be important resource wells and economic opportunities. Nanotechnology, which we've heard several talks during this conference about, biological and biotechnological technologies, and renewable energy technologies. So we have problems, we have possible solutions or things to draw from as resources. Well, that sets the stage for looking at the least developed countries. This is from the United Nations. This shows in brown some of the least developed countries or regions. I'm going to focus on one in particular, Bangladesh. But you can see that the opportunities in Africa are numerous. So the one that I'd like to highlight is one in Bangladesh from a company and a way of doing business highlighted by Grameen Shakti. And this is based on the idea of rural development and rural engineering. Yes, rural engineering, where we have some unique characteristics that have made Grameen Shakti able to install millions of small solar energy systems for development of the country. And it's become a very successful program that is trying to be modeled in other regions of the world because of its success. Now, a book was written about this by a colleague in Germany. Her name is Nancy Wimmer, and this is one of two books. And of course, this foreword was written by Mohammed Yunus, a Nobel laureate. And of course, many of you have heard his name before. So those who want some more information about this, I'm going to give a brief description of it, can go to this book or her second book. So here's the introduction. You want to provide just a small amount or a moderate amount of energy to people in rural environments where it becomes cost prohibitive to put large-scale transmission lines. It can make an enormous impact on those people's lives if they have lighting, a lamp or TV, or some way of doing business. When the sun goes down, it could make huge amounts of economic benefit to those people. How do you do that? So that's the business model of the Grameen Shakti. They provide a photovoltaic panel, a charge controller and switch, a battery, and then lives change. And so the mechanism for this is to be able to do this again to villages, to systems in which getting and transporting materials, industrial materials, products becomes problematic because of weather and because of roads and because of infrastructure. And these are problems that much of the developing or the less developed world has. So again, it's hoped that this can be replicated in other areas. All right, this diagram is one that I created. It's a systems diagram, and it shows the flow of how this positive feedback can work and what Grameen Shakti as a business can do. One of the things that Grameen Shakti provides is microloans. So many people know Grameen Shakti or Grameen Bank as a micro lender. And so the idea here is not just to provide the technology, but to allow the customer, the small customer, to see what the benefits are of their system and when they will be able to pay it back. They make a loan to that customer, they do the installation to that customer, the servicing to that customer, and all of this happens at the rural level through regional offices. So here we have this first arrow. Customer financing is where the business Grameen Shakti intervenes. They have local manufacturing hubs, so you don't have to transport the finished materials to the local villages or the local area. They're made there. They're made there and they are installed there. You can see here a local entrepreneur is involved in installing these. Local entrepreneurs build the charge controllers. All of the servicing is done local. So you have local employment. So the manufacturing hubs are trained by Grameen Shakti. You have a technology and innovation support. And again, all of this supported by locally trained rural engineers. That's part of the business model here. There is, of course, a delay in this. This takes some time. But then there's market acceptance. As people see in the villages that these work, then they want them themselves for their businesses that they're doing, for their houses. So they see that there's an economic advantage. And then, of course, there's a delay from market acceptance into customer financing again. Okay, we'll pay for this system because we see that this makes business sense for this small business neighbor that we might have. But there is a positive feedback here, supported by local technology centers, training schools, and village entrepreneurs. And it's a virtuous loop that feeds back on itself, usually starting with the village elders or someone who is prominent in the community. And then as market acceptance is it is undertaken and proven, more customers come in, more financing, and it becomes a virtuous cycle stimulated by Grameen Shakti. So this actually can be modeled. I hope that somebody listening might use a systems approach to modeling such a system for another country, maybe even for Morocco or for other regions, because it has worked here in Bangladesh. Okay. So, with that, I also have to show, of course, that photovoltaics has come a long way. We have agricultural or agri-photovoltaics, building integrated photovoltaics, bifacial PV, floating PV, and of course, you saw in the last slides, you have small-scale PV for rural villages, completely scalable from one side to the other. So here, just to focus on the agricultural PV for a moment, you can see that even that has a lot of diversity. Here's a system in France which has shown to increase the production of the crop, in this case grapes, as well as generating electricity. Shade provides increased yields, and there's a lot of studies that are being done for that. Here in the United States, it uses a tracking system. This is maybe a non-tracking system in France. There is systems that track automatically because they have a cylindrical shape. Taka Solar was doing that, silicon-based, by the way. And then here's a system for growing vegetables again. So agrophotovoltaics has a lot of diversity in it as well. And this can be adapted depending upon the crop, the country, and the environmental conditions. So that's just one of these. Each one of these pictures that I've shown has diversity within itself. So there now is a diversity of different kinds of form factors and products in solar, which highlight specific needs to a specific region. And that is, of course, one of the key points in doing energy development and economic development in the less developed countries. All of this diversity in products. All right, so I said that without economics, we can't make this work. And so there is a tool, there are a number of tools. This is just one of many. This is called the RET screen tool. It's used to calculate the economics of new energy technologies. That would be solar or wind or biomass. It can be downloaded for free at the website that you see below. And it's an Excel-based clean energy project analysis software that helps decision makers quickly and inexpensively determine the technical and financial viability of potential clean energy products. Then one can go to a bank, not unlike the Grameen Shakti, for microfinance or larger scale finance and say, look, the numbers match. We can look at the technologies for this particular region with this particular resource, and we can show how this makes sense. And this is one of many different types of software tools that are available in this field of techno-economics for renewable energy. This is used by students, researchers, and planners. They all use these tools. So in conclusions, there's the S there. What is needed? This is the emerging markets and developing economies represent a big opportunity. Looking at things from this value migration perspective can help set development priorities. How? One could look at the development pathways that have already been used by other countries and learn from their lessons, maybe leaping over into areas where things are now. Things can be done in a different pathway. Among less developed countries, there are numerous success stories. I gave you one from Bangladesh. There's a great diversity in renewables like solar and in particular PV. I've shown some of that. And there are techno-economic assessment tools are available. And I might add that they are essential as well to bring these technologies rapidly to scale and to the market. And that's important. The to scale part requires investment. Unfortunately, currently just 15% of clean energy investments flow to emerging markets. We need 1.7 trillion by 2030. This will allow the planet to be on track to make net zero carbon by 2050. So 15% now, but we're going to need 1.7 trillion. This sentence has a little bit of problems, but I think you see the output here. So the further reading on this is that the World Economic Forum's network to mobilize clean energy investments in EMDEs. They've assembled a playbook of different solutions, like the one that I highlighted in Bangladesh, to help unlock the capital needed for these nations to make their energy transitions. And I thank you. If anyone would like to contact me, I have some slides there at this this website where I've done this kind of presentation before. I am involved in both the research side and I consult to various companies doing technology and techno-economic assessments. So with that, I see that I've stayed on time, and I'm open to any questions that you might have.